So this meeting is being recorded to assist with record keeping and perhaps be broadcast at a later date. If you are unhappy with this, please leave the meeting now. But I hope no one leaves because I think it's going to be a very good talk from Rosie. So I'm just going to start tonight's session just by telling you a little bit about my project and what I do. So I'm Danny, obviously, and I am the Dark Skies Officer for Partneriaeth Project Norse for the Night Project. So as I say, I'm a Dark Sky Officer. This is immediately what people ask me. This is my job and this is what I do. No, I am nothing to do with Star Wars. I work for the Dark Skies Partnership, so you can find us Project Norse on Instagram and Facebook and all the social medias. But that's a partnership between Snowdonia National Park, which is a dark sky reserve, and then the AUMBs. So we've got the Clwydian Range and Dee Valley, Llyn Peninsula, and also the Isle of Anglesey, AUMB. So as I said, the National Park of Snowdonia, we are a dark sky reserve. We're one of only 13 in the world to have that designation, that designated status and that level of protection for our night skies. We've had that since 2016. It's something that we're really proud of in the national park. And I'm working with the AUMB so that they can get their own designations, so that they will also have layers of protection when it comes to darkness, which is really exciting. So what is a dark sky reserve? So it's International Dark Sky Week, and that's been organised by the International Dark Sky Association, or the IDA. They are based in Arizona, and it's them who look after the dark sky places and tell us and give us the criteria for that we have to meet, which is actually a really high criteria for us to get the designations. And they have the power to give us the designations, but they also have the power to take those away if we're not keeping up with our light pollution levels. So a dark sky reserve is a public or private land of substantial size, possessing an exceptional or distinguished quality of starry nights and nocturnal environment that is specifically protected for its scientific, natural, educational, cultural heritage and or public enjoyment. So a lot of my job is taking people out to enjoy the night skies, which is lovely when I'm allowed to do that. For the meantime, we've had to settle for Zoom talks, but that's really good because I get to have people like Dr. Rosie, who has come, and normally it would be a very long way for her to come, but with the power of Zoom, she's able to just be on our screens. So what is a dark sky? It might seem like a bit of an odd thing because everyone has a nighttime and everyone gets a dark sky, but not all dark skies are equal, unfortunately. So in terms of the IDA and reserves, it's an area where the stars are visible to the naked eye, so you don't need any equipment really to see the stars. I'm very lucky where I live, I can just pop my head out the door and I can see the Milky Way, which is something not many people get to do anymore. It's somewhere where there's very little light pollution, which we're very fortunate. We have naturally very little light pollution and we're working to reduce the light pollution we do have. And it's usually in a national park or a protected landscape like the AUMBs. So only 2% of Britain's population receive a truly dark sky. And that's why it's so important that we do this work, because we are losing our view of the night skies, and light pollution is a massive issue across Europe. When I first saw this statistic, I thought that cannot possibly be true, but I grew up in a very dark area, so I was a bit spoiled, to be honest. But then when you look at light pollution maps, these are really cool. You can find these if you just type in light pollution map onto Google. You'll come up with something that looks like this. And this is basically a load of data and a load of images that's collected by satellite. There's probably much more scientific theory that goes behind it than that, which I'm sure Rosie would be better to explain than me. But you can see all the light pollution across Europe. And in fact, light pollution is growing as a problem around 6% a year, which is really quite big. The areas that are red and white, they're areas with the worst light pollution, so you wouldn't see any stars at all in those areas. So you can see around Belgium and the Netherlands, and our big population centres in the UK, like obviously London, Manchester. But what's interesting is that you can see not only is it the land that we are having an effect on, it's also our seas. So you can pretty much pick out the shipping channels, like the English Channel, Holyhead to Dublin. And then these ugly blodges up here, they are oil rigs, which I didn't realise sent up so much light pollution. So we're having an impact on our coastal environment as well as our terrestrial environment as well. But if we zoom into Wales, you can see in Wales that we are defined by our darkness pretty much. The outline of the country is so dark, and these great middle bits here. But if you are in these major population centres, this is probably the closest place that you can get to where you're going to have guaranteed view of the night sky when it's not cloudy. But we are working across these big areas. So you've got the National Park here, we've got the Clwydian Range and Dee Valley, the Llyn Peninsula, which is so dark at the end that you can't even see it on the map here, and of course Anglesey there. So that's basically the areas that I work over, but we've got some really great pockets of darkness in the Brecon Beacons too, Pembrokeshire and the Cambrian Mountains. So we're pretty much spoilt for choice in Wales when it comes to dark skies. But my job is to try and reduce the light pollution and make sure that we don't get any lighter. So I'm going to stop talking now because you've all come here to listen to Rosie like me. So I'm really excited to hand you over to Dr. Rosie Johnson, who will be giving her talk on the aurora. Thank you, Rosie.
Great, thanks, Danny. I will do the obligatory sharing my screen. Please let me know if at any point you can't hear me or can't see anything that I'm talking about. I've got quite good internet connection here, but you know, still Wales. So thanks so much, Danny, for inviting me here today to speak to you all. I'm really excited to talk to you about the Northern Lights, as this has been a focus of my academic career, really, and I've been passionate and interested about the Northern Lights for a really long time. So yeah, I'm Rosie and I'm an associate lecturer at Aberystwyth University. And my journey with the Northern Lights really started at Aberystwyth University, where I did my undergrad degree. And during my degree, which was physics and planetary space physics, I had the amazing opportunity to study in Svalbard, which is this little island at 78 degrees north up in the Arctic Circle. And there we did some field work, and I got to use these optical instruments as well as radars to study the Northern Lights and the Earth's upper atmosphere. So after I finished my degree, I thought, what could be better than studying the Northern Lights in the Arctic than using telescopes in Hawaii to study Jupiter's Northern Lights? So then I did a PhD at the University of Leicester, studying Jupiter's Northern Lights. And following that, I decided to have a short break from academia, and I worked as a Northern Lights tour guide in northern Finland. So this is my aurora selfie here, me and the Northern Lights in my very stylish outdoor guide gear. So today I'm hoping to answer some of the questions you might have about the Northern Lights. How were they made? When is the best time to see them? Where is the best place to see them? Those sort of questions. And if I don't cover it in this presentation, then more than welcome to answer your questions at the end. And hopefully this will give you some ideas for when maybe we're allowed to move, even to go to Northern Scotland, maybe to have a chance to see the Northern Lights. So let's get into it. This is a video from the International Space Station. So this is a time lapse. So the astronauts on the International Space Station have taken a series of photos out of the window, and then they've sped it up to make it into a movie. So here we are, we're flying over North America, and you can see the Northern Lights in the Earth's atmosphere, this thin layer here. So the Northern Lights is this bright patch of light. It's typically pale blue-green, but it can also be red, purple, pink, and blue. And it makes arcs, and these arcs can ripple. And as this is a kind of sped up through time movie, you can see them flashing on and off. And you can see also they make some lovely curtains there as well. And the video there just finishing as the International Space Station rotated into the day side of the Earth. So that's what the Northern Lights look like from space. But what do they look like from the ground? So this is a video taken in real time. if it decided it wanted to go to the internet. Okay, oh, it's just informed me that my internet connection is unstable, just as I decided to stream the YouTube video, wasn't it? We might have to come back to this. Of course, it's now broken. But this is often quite a typical picture of what you see when you're looking for the Northern Lights. A dark sky with nothing there. But I mean, if you were somewhere nice and dark, you would expect to see stars rather than nothing. Apologies, it seems to have just broken. I'll just give it a minute. Okay, I've got it working. We couldn't have a Zoom talk without a technical issue. So that was the obligatory technical issue, and now we're back on the Northern Lights. Okay, so this is a real-time video, so it's taken with a really amazing camera. So you can see the people there, they're moving, and then in real time, the aurora is moving above them. So this gives you an idea of what it would be really like to see the aurora. If the aurora is really active, this is a sort of motion that you can expect to see. So it's the real speed. And this video is made up of 10 years of footage from this tour guide company in Alaska. So you wouldn't expect to see this aurora being this amazing every day. You'd be really pleased if you went on holiday and you saw this just one time. So the colours in this video, they're quite realistic of what you would see with your eyes. So when the aurora comes above your head and it fills the sky like this and it's all moving around, it's called an auroral corona. And this is when you can expect to see more colours, so more than just green, usually seeing the purple bit at the bottom. And so this is a really beautiful video, but it goes on for quite a while, so I'm not going to show the whole video. Maybe I can send the link so that you can watch it later. Okay. So we've had a long fascination with the Northern Lights, and there's many myths and legends behind how the lights are created. In many cultures, the Northern Lights is associated with bad luck, and in some cultures, it's associated with good luck. So some places it's associated with life, and some places it's associated with death. And many cultures associate the lights with deities. But here are a few of my favorite stories. So I was a Northern Lights tour guide in Finland, so I couldn't miss out the opportunity to tell you about the Finnish tale. So in Finland, the Northern Lights are called revontulet, and this means firefox. So the story goes that as the fox runs across the snow, the Northern Lights spark off the fox's tail. And another myth that I really like is from the Arsenerit Inuits. So they believe that the Northern Lights is created from their ancestors, from their Inuit ancestors, their spirits playing football with a walrus skull. But interestingly, the people of the Nunavik Island, which is close by, they see it the other way around. They believe it's spirits of walruses playing football with the skulls of their Inuit ancestors. So I think it's really interesting that they have these two interpretations of the Northern Lights, but see it the other way around from each other. A little bit closer to home, in Scotland, the Northern Lights are known as the Merry Dancing Men, and they're believed to be the souls of soldiers. So we've had a long obsession with recording the Northern Lights. So in 660 BCE, there are records from the Syrian astronomical records of the Northern Lights. And in this Babylonian clay tablet here on the top left, this contains records of the aurora. So it refers to a red glow that was seen on the 12th to 13th of March in 567 BCE. There's also records from China dating back to 193 BCE, and those stories of the aurora from those texts, they link to legends of dragons. So to reach low latitudes, these storms have to be massive. And because these auroral events are so big, they must have had such a great impact on this cultural history. And here's another one in the bottom left. This is an illustration from a massive auroral Northern Lights event that happened in 1770. And it was witnessed in Japan. And here's an illustration of what they saw. We've also been recording what's going on at the sun for a really long time. And there was another major event that happened in 1859. So Richard Carrington, he was observing the sun, and he was taking illustrations of these features called sunspots, which are dark spots on the sun's surface. And those sunspots are linked to solar activity. So he was observing these sunspots when he suddenly noticed two patches of intensely bright white light coming out of these sunspots. And then later on, it was observed that there was aurora across the globe. So scientists have looked at the, and historians have looked at the meteorological records of sailing ships from this year, and they found lots of records from Cuba, Bahamas, Hawaii, saying that these the people on these ships have witnessed the aurora at such low latitudes. And then came Christian Birkeland. He decided to investigate the connection between the Northern Lights and the Earth's magnetic field. So this involved him taking a team of Huskies and going on an expedition to northern Norway. So he took his compass and he noticed that the needle of the compass, it was moving, it was shaking around while the Northern Lights were happening. So he made his planetarella, which is pictured here in the bottom right. He made this chamber and he made it almost a vacuum, but filled it with some charged particles. And he had some metal spheres, which he gave, he made sure they were magnetic. So he kind of made this mock-up aurora. So how are the Northern Lights actually created? So it's a process that starts at the sun. Now, the sun is really hot. It's a nuclear powerhouse with the hydrogen fusing into helium, and it makes the core of the sun 14 million degrees Celsius. And this heat causes a layer of the sun to convect and mix around. And all of this mixing makes a super strong magnetic field. Now, because the sun is so hot and space is very cold, the particles from the sun are being constantly stripped off the sun's surface. And those charged particles, they drag the sun's magnetic field with them into space. And together, this is known as the solar wind. So the solar wind travels through space and it reaches the Earth and it interacts with the Earth's magnetic field, allowing charged particles to flow down the magnetic field lines into the Earth's atmosphere, where they hit the Earth, where they hit the gas and they excite the gas, making the gas produce light. So I wanted to show you a little clip from this video. So hopefully I have a good connection to show. So here's the Earth and its magnetic field. Here comes the solar wind, which contains the Earth's magnetic field. Oops, I'm not sure it's working for, sorry about that, I think it just restarted. Right, Earth's magnetic field, Sun's magnetic field. When they are pointing in the opposite direction and they get really close, the magnetic field lines break apart and reconnect, sending those particles streaming down into the Earth's atmosphere. Those magnetic field lines are then pushed over the top and bottom of the Earth, and then they begin to pile up on top of each other, where they reconnect and then send more particles firing back towards the Earth. This process makes a complete ring around the North Pole and the South Pole, giving us our northern and southern lights. It's obviously crashed again. Maybe we're... Oh no, I was trying to play a video. Start from that slide. Okay, so the Northern Lights, it's a process that happens in the topmost part of our atmosphere. So that's above 80 kilometers above the Earth's surface. So for context, we get most of our weather, so most of the clouds exist at just under 10 kilometers above the Earth's surface. They don't go above 10 kilometers. And this is about the height that aeroplanes are also flying. So of course we need cloudless nights to be able to see the aurora. Now, as I said before, charged particles are coming from the sun and the near space environment around the Earth. They're getting accelerated down the magnetic field lines, entering into our atmosphere, where they hit the gas and they excite it into producing light. So if we have really, some particles that don't have loads of energy and they come in and they hit oxygen above 200 kilometers, then they make the red aurora. If those charged particles have a little bit more energy, they're able to get past 200 kilometers further into the atmosphere and they hit the oxygen, then they'll make the green aurora. And if we've got a really energetic event where the charged particle can make it all the way down to 80 to 100 kilometers above the Earth's surface, then they can excite the nitrogen into making purple aurora. So sometimes you might hear about people talking about how the Northern Lights can be more active in some years than in others. And the sun goes through this cycle, which takes about 11 years. So the last solar cycle 24, started in 2008. So this is a picture of the sun in the X-ray wavelengths. And you can see that there are some dark patches here. But as we move towards solar maximum, so away from solar minimum, the sun is becoming more active. And you can see that there's more brighter patches, and the sun's atmosphere, which is known as solar corona, this is getting thicker. So then we move through to solar maximum, which was around 2012. Then the sun moves past solar maximum and returns to a more quiet state, which actually has only just finished. So we've only just left the previous solar cycle. We're now in solar cycle 25, and we're moving towards solar maximum, which should be in 2025. So when we're at solar maximum and the sun is more active, there can be a lot more solar eruptions. So the sun's magnetic field can get a lot tangled up quite a bit during solar maximum when it's active. And sometimes bits of the solar magnetic field can protrude from the sun's surface and get twisted up until it's ripped off the surface, like an elastic band stretching that breaks, and then it throws loads of charged particles out into space. And if one of these solar storms hits the Earth, then we could be in for a really nice aurora. So this is a little video here from the SOHO spacecraft, and it's blocked out the sun so that we're able to see the solar eruptions, just a bit like how when you're looking into distance and you need to block out the sun, the spacecraft has done that for us. So you can see a couple of solar eruptions here, a couple over there, one down there, and then this last one is really big, and it actually goes towards the satellite and it hits the satellite, and all the charged particles, and they interfere with the electronics in the satellite, which causes all these dots that you see in the image. Now, everyone gets really excited about solar maximum and these solar storms and how they can cause really great aurora, but that doesn't mean to say that we can't see aurora at solar minimum. So here's a picture on the right of the sun at solar minimum. And you can see that there are some dark patches, and these are known as coronal holes. These are really good if we want to see the aurora, because this means that the solar wind can come out of these holes quite fast, and it can come out, and if they're facing the Earth, it can hit the Earth and sort of interfere with our magnetic field and excite some really nice aurora. And when I was working in Finland, I would look forward to these holes returning because they're quite long-lived features. They can stick around for several months. And this one, for example, at the equator, that will take 24 days to rotate around the sun. So this feature, this hole, can come back month after month, giving us a regular aurora every month, which was quite nice to look forward to. Oh, that little video played again. So where is the best place to visit to see the Northern Lights? So you can actually be too far north to see the Northern Lights. The Northern Lights make this ring around the pole. So if you were at the North Pole, you wouldn't see too much. And same for the Southern Lights. But there isn't so much landmass under the Southern Lights that's easily accessible. There is, of course, Antarctica, but that's quite hard to get to. So with the best places to see the Northern Lights are anywhere under this auroral oval, as it's known. So this is a model from the NOAA Space Weather Prediction Center. So this is a forecast of what the aurora could have been like yesterday. So if you want to choose somewhere to go and see the Northern Lights, then Northern Scandinavia is good, Iceland is good, Greenland maybe, Canada, Alaska, and Northern Russia. But as you can see from this video, the Northern Lights, the auroral oval, it can grow and expand and change in shape and size. So there's no one perfect place that you will guaranteed always see the aurora. As Danny was introducing this talk, one of the best places to see the Northern Lights is a place that is very dark. You want to be away from light pollution, as this will allow your eyes to be able to get used to the dark, and you'll be able to see as much of the aurora as possible. If there's too much light pollution, it would be too hard to see it, as it can be very faint. This is an image of the lake next to the hotel that I worked at in Finland. I'm not saying that the hotel that I worked at was the best place to see the Northern Lights. It was nice, but what I'm saying is it's nice to go somewhere that is remote. It's nice to stay in a place that is remote. So you can, for example, I could walk to this lake within 30 seconds of my house. So it was very easy for me to just pop out and check. as you know, it's also usually cold where you see the northern lights, so it's nice to be able to pop back in when the aurora isn't there and you're feeling a bit cold. So aim for somewhere that you have a dark sky, very easily accessible, and just take into consideration, if you're going to stay in a town, how long it takes to drive out to that dark place. You might like to also consider going somewhere more continental, like Finland, rather than the coast of Norway, just because typically it gets more cloudless nights. But then also you could get some really cool fjord reflection photos of the aurora. So when is the best time to see the northern lights? So the northern lights, best time of year is around the equinoxes. So in the spring and the autumn equinox. This photo was taken during the spring equinox, and we had really, really spectacular aurora then. It was really great. The winter is better to see the northern lights, but only because the nights are longer and the nights are darker. In the summer, the northern lights, they don't disappear. It's just obviously we can't see them when the sky is so bright. The best time of day, well, best time of night to see the aurora is usually around midnight. They're most active around that sort of time, kind of to do with the geometry of the system, about how the magnetic field lines were piling up on the night side. So the aurora tends to be more active at that time. But you can see aurora anytime from when the sun sets to when the sun rises. It's not always very predictable. In this case, the guest had just gone on a snowmobile tour, which started at 8 p.m. and finished at 10 p.m. We didn't really see any aurora until we got back. We saw a quiet arc, and then that arc erupted into aurora that filled over half of the sky. So how can we predict or forecast the northern lights? So I like to start off by going on spaceweather.com. This is a really nice website to use to get an idea of what's coming up for the next few days. So I checked out the forecast for yesterday, and spaceweather.com told me that there was some solar wind coming. So there was a coronal hole, which you can see pictured on the right-hand side there. And the fast solar wind is streaming out of this hole, and it hits the Earth. And yeah, they said it might hit the Earth on Wednesday evening, or it could be Thursday, and it's not always sure. And it said that it might not cause a geomagnetic storm, but it could boost auroras. But in the end, it actually did cause a geomagnetic storm. I checked this morning and I found some photos on spaceweather.com. So here's an image of the aurora from last night. This was taken by a photographer in Finland. So in the end, that coronal hole, the fast solar wind, it did cause a geomagnetic storm, and it caused quite bright aurora. So solar minimum isn't so bad, but maybe we might have to wait until solar maximum to see the aurora in the UK. Yes, so I also like to check the KP forecast. So the KP index is all about the Earth's magnetic field. It's a scale from 0 to 10, and then KP5, that corresponds to G1, where G1, 2, 3, 4, 5, those are geomagnetic storms increasing in strength from 1 to 5. So the thing is about KP index is it's averaged over about 3 hours. So it's saying that the Earth's magnetic field will get disturbed. It will be maybe a geomagnetic storm in that 3-hour period. However, we can't say for sure when exactly in that 3-hour period it will happen. So I know a lot of the time people download apps and they get notifications when the KP index changes. However, just because the KP index has increased, say at like 10 p.m, doesn't mean the aurora will be immediately there. So I like to use spaceweather.com and the KP index to give me an idea of which day of the week the aurora might be active. So if we look at this report from yesterday, I would say that yes, Wednesday evening looks interesting. It has potential. Friday, not so much. And Saturday, I might not be interested in, depending on how sleepy I was feeling. If you're on holiday, you might want to stay out every night and look for the aurora every day. So with the KP index, like if there is more activity, then we can see the northern lights at lower latitudes. So this plot of the Earth shows us for KP1, we're probably only going to see the aurora quite high up in like northern Scandinavia, northern Iceland. I got this image from a Norwegian website, and that's why Tromsø is labelled capital of the aurora for Norway, I think. So KP2, 3 and 4 you can see throughout Scandinavia, and we're looking for KP5. If anyone on the call is in Scotland, you might be able to see it there. But down here in Wales, we're after something around KP7. And we probably won't see KP7 until solar maximum. But you know, you never know. It's always worth looking at the forecast. So just to note that this, the Aurora Forecast app I use is Aurora Forecast 3D, but there are many out there. So these two, the website and the app help you work out which day to pick. And then on the evening, if the weather forecast is good and you've got a clear sky, I like to also check the interplanetary magnetic field. And this might sound quite complicated, but the takeaway message is that you just want to check if the BZ is south. If this number is negative and it's south, then that means that the configuration of the Earth's magnetic field and the solar wind is good to go for making aurora. If it's northward, no matter the activity from the sun, it's not going to be very favorable conditions for the aurora. So we want this to be south. And you can find that out. This was taken from the Space Weather Live app, or just spaceweather.com as well, shows you the BZ. So that can be quite helpful to know if there's going to be aurora on that evening. Another trick is to make use of webcams. So quite a few places have all sky cameras, as they're known, where it's a camera facing directly upwards and it has a fisheye lens so you can see the whole of the sky. And this is one from Hankasami Observatory in Finland, so you can see the whole of the sky, and around the edge is the horizon, and there's the observatory. So this is orientated north at the top there, south at the bottom, east, west, and you can see the sun is setting. And as the sun sets, we can start to see the stars, and there's Jupiter, my favorite planet. So now I'm looking north because this is at this latitude, the northern lights should be here. And I'm going to look and see if anything happens. And I start to see a glow. And as this is a time lapse, it happens very quickly. But if I saw this in the webcam, I might think maybe it's not worth going out yet. But as it gets brighter and the aurora moves further south, if it was colourful like that, I would definitely race outside to see what I could see with my eyes. If there was an arc that came completely down through the centre of the webcam, I would definitely race outside as well to see what was going on. With this video is just finishing there with a cloudy sunrise. But there's lots of other webcams dotted all around the most popular tourist spots that you can check out. So, is it possible to see the Northern Lights in the UK? Well, I'm sure you've seen on the news, everyone gets really excited when there are sightings in the UK. And I've actually seen the Northern Lights myself. So I grew up in the Northeast, and I remember my dad putting us in the car and driving us out to go and see the Northern Lights. And I remember it looked a bit like a funny green cloud. But here are some nice photos of the Northern Lights taken from the UK. So on the left, we have another one from the northeast, aurora over St. Mary's Lighthouse. And then on the right, we have some aurora possible to see the Northern Lights in the UK. And as well as using spaceweather.com and checking the KP index, I recommend that you use the Aurora Watch UK app. So the way the Aurora Watch UK app works is that it monitors the Earth's magnetic field, and it does this with magnetometers. So these instruments measure the variations in the Earth's magnetic field, a bit like Christian Birkeland when he had his compass and the needle was moving around due to the aurora overhead. So you can see in this plot where it's wiggling, that means that there is aurora overhead. So Aurora Watch UK, they have like, normally it's just green when aurora can't be visible. But this was last month when there could have been aurora visible. So yellow alert is visible in the UK, but only in the extreme north of Scotland. And then amber alert is aurora visible from Scotland, Northern England and Northern Ireland. And then we have also red alert for when it's visible further south in England and Wales. So it's worth downloading that app in advance of Solar Maximum, you never know. And you can get it to send you notifications. I also like to check out the Shetland Cliff Cam. I find myself when I'm missing out on aurora, I like to see if they can see it up in Shetland. So again, like in the Hankasami, like in the video I just showed before of the aurora, this is a camera facing north. So if the Northern Lights are visible, they will be in the northern part of the sky. And of course, since I'm in Wales and maybe many of you as well are in the call, if they are seeing the Northern Lights in Shetland, Shetland is quite far north compared to us, so there's not always a chance that we will see it. However, if the Northern Lights is, you know, filling up the whole field of view and it's super bright, there might be a chance of seeing it in Wales, but as a sort of smaller glow on the northern horizon. So just give a little bit of information now about how to take photos of the Northern Lights. And you can use your DSLR, or if you've got a point and shoot, or in fact, you can now use your phone to take a photo of the Northern Lights if you've got a nice new phone. So whatever camera you're using, you're going to need to put it into manual mode. And this is because, and well, unless you've got one of those really posh cameras that can take real-time videos of the Northern Lights. If you do, then maybe you should take over this talk right now. But I'm assuming you don't, so you're going to need to manually put in the settings. If you're somewhere really cold, like Lapland, and there's snow everywhere, you'll need to have spare batteries, because batteries don't work very well in the cold. So if you have a spare battery, keep it on the inside of your coat, so that when the other one runs out, you can quickly switch them over. You'll need to focus your camera onto infinity. So sometimes on some lenses, there'll be the little infinity symbol and you can just turn it to that. Some lenses even have a lock, which is nice. Other lenses, it's typically turn it all the way and then back just a little bit, and that's usually infinity. You can practice in the daylight by focusing something in the distance. And then once you've got it right, then you can put a little bit of sellotape on the outside of the lens. Don't worry, not like on the actual lens itself, like so on the outside plastic housing. And then that means that the you know, when you're filming it, when you're taking pictures in the dark, it doesn't slip. Or you can focus it on the night. If there's some bright stars, you can just focus it on them, or planet like Jupiter. Or maybe if there's a street light, but hopefully it's really far in the distance and not bothering your dark sky. We need a high ISO. So ISO is the sensitivity of your camera. to light. So since the aurora, the northern lights is really faint, we need to use a high ISO. And by high, I mean above 800. So, and then the upper limit of this will depend on your camera's capability. So I'd recommend not going all the way to the highest ISO that your camera or phone can have, just because if you go all the way, then the photos can end up looking a little bit grainy, a little bit noisy. Then we also need a slow shutter speed, so a long exposure, as we need enough time to let the light into the camera. So I like to start off with maybe like 30 seconds, just so that I know I've got the aurora, I've captured the northern lights, and then I've got the composition that I'm interested in getting. And then after that, once I've got the composition, I'm happy with the photo, I then tend to reduce the exposure to about 10 to 20 seconds. Or if it's really active, try to get it below 10 seconds, maybe even below 5 seconds. As if you have it too long, then the aurora can kind of, if it's moving a lot and really active, it can get a little bit blurry. We also need a wide aperture on the camera. So like with your eyes, when your pupils dilate in the dark, we need the camera to have a wide aperture as possible. So this means a low f-stop. And then you can manually change the white balance if you like. So if you let your camera automatically do it, then it might not be the colors that you believe that you saw. So typically I like to use quite a cool white balance, so like 2700 Kelvin, or you can, but if you shoot in RAW format, you can change this afterwards, and you can edit the saturation and the exposure to how you feel you saw the aurora on that night. We also need a tripod. This is very important when we're having a long exposure. It's very hard to hold your camera still, especially for 30 seconds. It would be impossible. If you're shooting with your phone, then you can use a toilet roll tube as a makeshift camera stand. It's also quite nice if you have a wide angle lens, maybe even a fisheye lens, but this is not essential. So quite a lot of the time when you see in like holiday brochures or something, pictures of the northern lights, they always look so bright, really, really vivid. And sometimes people complain that they look really fake. And it is different. The camera does see things differently to how your eyes see it. So in the daytime, your eyes usually, so yeah, your eyes are how they see, they make, your eyes use rods and cones to see. And in the daytime, the cones work really well and they're good at detecting color, but they're not so good at night. At night, the rods take over and they don't really see in color, they see grayscale. So that's why sometimes when people see the aurora, they don't really see the green. And this photographer has tried to replicate this. So the top images are what he believed his eyes saw, and the bottom images are what his camera captured. So we all kind of see color differently anyway. Our eyes have a maximum sensitivity at 550 nanometers, which is actually the same wavelength as the green aurora. So that's good. At least our eyes are very sensitive to that color. But yeah, what I'd say is like you can edit your photos how you wish, how you feel you saw it on the night. And that might look different to how other people see it. But then also, you know, when you're going to see the northern lights, maybe be prepared that it's not going to be bright green like grass. It's like a pale blue-green. And sometimes when it's not very active, when it's quite faint, it will just look like this sort of, people have described it like a white rainbow in the sky. But if you're lucky, you'll see that beautiful aurora corona, and then hopefully you'll see all of the colors. So I couldn't do this talk without mentioning the northern lights on other planets. As I did mention, I studied the northern lights on Jupiter. but Saturn, Uranus and Neptune also all have northern lights. So these images, they're all images of the planets in, so this is Saturn in its visible light, and then superimposed on top of that image is the UV aurora. And so we study the northern lights at other planets, and this gives us a really interesting view of the atmospheric chemistry of the other planets. I'll just play you this video now of Jupiter's northern lights. So you can see that they're really active. It's got this oval, but it's also got this crazy bit in the middle that's really shiny and active. And it's also got this dot and tail around the outside, which is some northern lights due to interaction with one of its moons, which is really fascinating. So that's all I had to say today. I hope that I've answered maybe some questions that you might have. I'm happy to take some more questions, and I hope I've given you some inspiration for planning your Northern Lights holiday. Maybe that's in Northern Scotland or further afield once we're allowed. So thank you so much for spending time with me this evening, and welcome any questions that you may have.
Thanks very much, Rosie. That was so interesting. I loved all of your images. You had the best job in the world, I think.
Yeah, it was really great.
If anyone wants to ask a question, you have to remember to unmute yourself. You can also raise your hand if you know how to do that. Or if you're feeling a bit camera shy, you can type in the chat box. So if you hover your mouse on the screen, right in the middle, there's a little speech bubble that says chat. If you click on that, it'll come up and I can ask the questions for you. But you covered lots of different things, so I think everyone will be a bit overwhelmed. There's a lot of people saying thank you.
Yeah, great. Sorry that the video didn't work.
Oh, it's fine. That is just Zoom for you, isn't it? You can have everything ready to go and then the videos won't.
Yeah.
Yeah, it is interesting. I think I've seen the Northern Lights very faintly in the distance. I think as far as the Brecon Beacons, I saw them.
Oh wow, that's amazing.
Yeah, it's really far south, isn't it?
Yeah.
But it's interesting about the KP and the when you get the alerts on the Aurora app, because I'm in a few Aurora groups, and as soon as that goes off, everyone rushes outside and then gets really annoyed that they can't see it.
I know, it's always like that. Some of the guests would set it and it would wake them up at 3 a.m. and they'd go outside and they'd see nothing and then they'd be annoyed.
So how long did you say? It's like a 3-hour period?
Yeah, it's averaged over 3 hours. So and the aurora can change so much. It could come and go completely in that time. And you've just got to, it's kind of, it almost have to be in the right place at the right time sometimes to really see it.
Yeah, so you just have to really commit and go out for the 3 hours, or just
or you can try and like stay somewhere remote, and then you can monitor the webcams, go outside for 5 minutes, come back inside, monitor the webcams. That's what I did.
No, some people are sharing their Northern Lights experiences, like Dave, who said his first time seeing them was during a flight back from the US. While over Greenland, I was glued to the plane window whilst everyone slept.
Yeah, amazing. I've never seen them from a plane, but it must be so cool to see them from a plane.
I was actually flying to Newcastle from Bristol, and the pilots came over the tannoy to say, oh, we can see the Northern Lights, but they could see them from the cockpit, but because we weren't facing the same way as them, no one else could see them. So everyone was like, oh no, turn the plane.
That's really funny.
So you study the aurora on Jupiter?
Yes, yeah.
That's interesting. How do you even go about studying the aurora on Jupiter?
So there's a few telescopes. There's some in Hawaii and there's some in Chile. And those are the ones that I use. And I actually look at Jupiter in the infrared. So I showed the ultraviolet picture of Jupiter. And to look at Jupiter's northern lights in ultraviolet, we used to we need to use the Hubble Space Telescope. So there's a few ways that you can see. So you can use space-based telescopes, or you can use telescopes on the ground. And because they're so powerful, you don't really see them. You can really see them with your eyes in the visible light spectrum. You can only really see them at the ultraviolet or infrared wavelengths.
That's so interesting. I did wonder, you kept saying, oh, Jupiter's my favourite planet. I was like, what Jupiter got? Like,
I just did my whole PhD on it, so a bit of a soft spot. But it's like, its magnetic field is 10 times as strong as the Earth's magnetic field.
Oh,
it's
wow.
the biggest planet in our solar system. So it has the biggest northern lights in our solar system.
Wow. So we got another comment saying, I saw them in Iceland. Sophia, very lucky, only there on a day trip. There'll be lots.
Wow, that's so
very,
lucky.
Yeah, very annoyed at that, because I know people who've gone for months and not seen anything. And then we've got a comment saying, great talk, Rosie. Wondering, will any changes in the ozone layer have an impact on the aurora? That's a good question.
Oh, that is a good question. I'm not sure, because they are quite distinct layers. So the ozone layer is just above the troposphere. So I think that's like maybe at like 14 kilometers above the Earth's surface. And that's in the stratosphere, whereas the northern lights is up in what we call the thermosphere. So that's above 80 kilometers. So there's quite a large gap in between there. But it's a really interesting field of study, understanding how that top layer of the atmosphere, so how the northern lights does interact with our climate. But I'm afraid I don't know the answer to that question. I just know that it's a very interesting question, and understanding like how all the layers of our atmosphere are coupled and how they interact is quite difficult.
Well, it sounds like another PhD study, I think.
Yeah.
Another question from Kate, this time, asking, does wildlife react to northern light displays? Birds stopped singing when there was a solar eclipse.
Yeah, birds and other animals do react to solar eclipses, I think, because obviously it gets dark, so they think something's going on here. I've also read in these accounts of the massive aurora northern lights display, so these ones that were sort of recorded, like the 1770 display that made it all the way down to Japan and lower latitudes. Some of these were so bright that, people thought it was daytime, and they thought it was time to get up and go to work, and apparently birds started singing. So I think in these really big displays, which are unusual, the wildlife can react, and birds can be like, oh, it's daytime. But I'm not sure. I think at the northern latitudes where the aurora is there quite regularly, I think perhaps maybe they're used to it, but I'm not sure. Yeah, they might not. They might. Maybe they enjoy it.
No, it's really interesting, isn't it? And I suppose it depends how sensitive animals are to the magnetic field.
Exactly. Yeah, because recently there was a study about the beachings. There was some beachings of whales. I can't remember which whales it were, but they kept going off course and getting beached in England and also other places. Can't remember, but anyway, a few whales got beached, and they thought this was to do with the Earth's magnetic field, and there was like a big northern lights, a big geomagnetic storm, but it was actually something to do with the sun, and sometimes the sun makes these radio waves, and it was these radio waves that were confusing the whales. And so that was really interesting, because birds and other animals do use magnetic fields to navigate. So it was interesting to read about how the radio waves were confusing the whales.
That's really interesting, isn't it? We don't think about, we live in our world, but there's different elements, isn't there? The animals can see that we can't see. I don't think we've got any more questions. So anyone who does want to ask a question, you ask now, or you must forever hold your peace.
Or you're welcome to email me if you want any other advice on where to go to see the northern lights or anything.
Yeah, so if anyone wants Rosie's email or anything, you can contact me, because you'll all have my email. If you can all follow us on Facebook, we're called Project Norse as well, so we'll have more talks, and hopefully when real life starts again, we can have in real person talk. So maybe Rosie, you can come up one day.
Yeah, that would be great.
Do some when we're in the next solar maximum phase. You can do some Aurora watching.
That would be great.
Well, thank you very much, Rosie, and thanks everyone for coming this evening. I have got 2 more sessions this week. I've got archaeoastronomy tomorrow, which is looking at sites like historic or very prehistoric sites that have connections to the stars. And that's by Professor Clive Ruggles tomorrow evening. There's still space on that. And we've got a talk on meteorites on Saturday evening. Meteorites and shooting stars, and how you can spot them and potentially find some. There's been 2 found in the UK.
Yeah, amazing.
Bit of meteorite, I can't believe it. But yeah, thank you everyone, and thank you, Rosie.
Thank you so much everyone for listening, and thank you for your thank yous.
Okay, bye.
Bye.